Supervolcano threat. What if humanity could stop volcanoes, freeze glaciers, and control the climate? This might sound like science fiction, but scientists are already proposing real plans to do exactly that. In 1815, Mount Tambora produced the largest eruption in modern history. It ejected 80 cubic kilometers of debris and caused up to 100,000 deaths. The global dust cloud cooled Earth and triggered crop failures worldwide. But Tambora was small compared to supervolcanoes. The ancient Toba eruption released nearly 50 times more energy. If a similar eruption happened today, scientists estimate up to 1 billion lives could be at risk. There are roughly 20 active supervolcanoes on Earth. These are ticking time bombs capable of collapsing global agriculture, blocking sunlight. And instead of waiting for disaster, scientists have proposed harvesting energy from supervolcanoes. The idea: drill deep boreholes around magma chambers, inject cold water, becomes superheated underground steam, is pumped back up for energy. This would slowly cool magma, reduce eruption risk, generate massive geothermal power. Over tens of thousands of years, enough heat could be removed to neutralize the volcano entirely, and magma plumes form every 50,000 years, meaning this technology could help protect civilization long term. In 1991, Mount Pinatubo injected 20 million tons of sulfur dioxide into the atmosphere. This cooled Earth by 0.5 degrees Celsius for nearly 2 years. This inspired solar geoengineering. Inject sulfur into the stratosphere to reflect sunlight. Just 1 ounce of sulfur dioxide can offset several tons of CO2 warming for a year. But risks include unpredictable weather, crop failures, global political conflict over climate control. Another idea: a space solar shield placed at Earth's sun balance point. It would reduce sunlight by 1.8%. Enough to restore pre-industrial temperatures. Large-scale ecosystem engineering could stabilize Earth. The Great Green Wall in Africa aims to stretch 5,000 miles, capture 250 million tons of carbon, create millions of jobs, stop desert expansion. Scientists are also bioengineering life. Crops that grow 40% larger, algae that produce hydrogen, fuel microbes, generating electricity from wastewater. Even woolly mammoths may return. Hybrid mammoths could help keep Arctic permafrost frozen, preventing billions of tons of CO2 release. Mechanical trees can capture carbon using chemical plates. 1 artificial tree equals 1,000 natural trees. Deploy 100 million machines, and we could offset all global emissions. Oceans are also becoming acidic due to CO2. One radical proposal suggests detonating a deep-sea nuclear explosion to shatter basalt rock and absorb carbon. A single explosion could capture 30 years of emissions. Safer solutions include artificial reefs, coral habitats, seaweed farms. These can increase fish populations by up to 20 times and boost natural carbon absorption. The Thwaites Glacier in Antarctica spans 75 miles. If it collapses, sea levels could rise 10 feet worldwide. Proposed solution: build a 100 kilometers underwater curtain to block warm ocean currents. Other ideas include wind-powered Arctic ice, pumps floating polar umbrellas, artificial ice generation. These systems would restore reflective ice, cooling the planet naturally. But all these solutions require enormous energy.
Human energy use has grown 7,000% in 2 centuries. Covering just 0.3% of Earth's surface with solar panels could power civilization. Massive solar farms in deserts like the Sahara could generate 4 times global energy demand. But too much energy creates waste heat, potentially raising Earth's temperature by 20 degrees Celsius in future centuries. The solution: Space solar power. Orbiting solar arrays could collect constant sunlight beam energy to Earth radiate heat into space. China is planning a 1-kilometer orbital solar station, while other proposals reach 1.7 kilometers wide. To build space infrastructure, we may need a space elevator. A cable 36,000 kilometers long would connect Earth to orbit. Cargo could travel to space for under $100 per kilogram. This would enable orbital factory space solar farms data centers and space climate control systems. Beyond that lies the orbital ring. A rotating ring around Earth could enable global travel and hours host floating city support space industries launch spacecraft cheaply. But it will require billions of tons of material, likely mined from asteroids. If built, humanity could transform Earth into a fully managed, climate-stable world and expand civilization into orbit that TO protects civilization. We may have to redesign the planet itself, harnessing Earth, stabilizing climate, expanding into space. The future of humanity won't be accidental. It will be engineered.